Hello friends, let us discuss some more examples on the construction of minimum DFA. This will be some special types of examples. Many times that has been asked in even gates and also in the university exams. Sometimes the question is divided into two parts. First part, and then there will be either and or and there will be second part of the question. In such question, we can do either by directly or the second way by concatenation. When we have to concatenate two different types of language, we simply do L1 dot L1 is equal to D1 dot D2. That means we first try to make the deterministic automata for that part and deterministic automata for that part, and then we will join together. So let us see an example to understand it more clearly. So here is one question. We have to construct a minimum DFA that starts with A and end with B. So first we will try to write down the language starting with A. So this can be, the smallest string can be A, B, then A, in middle anything can come, A, B, B, but the thing is that starting with A, ending with B, starting with A, ending with B, starting with A, ending with B, and that's in this type of infinite string we can write. So the language here is infinite. So let us take the smallest string and try to construct the minimum DFA. Starting from the initial state, when we get A, we reach to another state, let us name it as B, and when again we get B, we reach to our final state. So this is the final state. But there is some restriction, because the restriction is that the string can only start with A. If it may start with B, then we have to go to the trap state, ordered state. From there we cannot come again to our final state. So this is our trap state. After that, whatever we will come, we will not accept, we will remain there only. So transition for A has been completed, transition for D has been completed, transition for B. What will happen if B will come? In such cases we will take it, because A has been come in, but any number of A can come. We will not neither reach to the final state, but wait for the B to come. So here this will be B. So transition for B has been completed. Now transition for C. If at last number of B can come, there is no problem, because starting has been completed and in the end we had B. So there is no problem whatever number of B comes. But if A will come, then we have to again wait for the next B. That means we have to go back to wait for B. This is, we can make directly by this way. One another way to make is that we can divide our question into two parts. That means we can write the language like in first part we can write the language, the part which is only started with B. B does not care what will come after, but we are only focused that the language is starting with only A. Such types. And the second part, B end with B. So that can be B, A, B, 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 A, B, whatever. So infinite. So if we concatenate these two languages, then our language, required language will come. So in such cases we can make DFA for L1, we can make DFA for L2, and then we can concatenate both. So let us try for DFA for 1. So DFA for 1 will be, if it comes A, we will accept it, and after that whatever come, we will accept. This is DFA. But if B will come, we will reach to the dead state. This is a DFA for language L1. Now DFA for language L2, ending with B. So what at initial stage any number of A will come, that's okay, but as soon as B come, we reach to our final state. and if a number of b will come, we will accept that, but if a come, we again return back. So this is the DFA for L1 and L2. Now we can concatenate, see how we can concatenate. Here we can see in our in required DFA we have two parts. The first part is this part, and second part is this part. So if we will look carefully, then we will find that here this part is actually L1 and this is L2. So here the final of L1 we had made initial stage of L2. So we had concatenated both the DFAs to find our required DFA. We will discuss some more examples later to make clear. So let us see one more example. Minimum DFA over A, B, C. Now the alphabet has been made, three alphabets are there, A, B, C, where starting with A and ending with B. So in such cases we can directly, let us try to make it directly. If it starts with A, we will accept the string, and if B will come, we will the language can be possible, like the language will be same as in the last case, A B, the language will be same exactly, but here the difference is that we have three alphabets. So this is the language, this is the DFA, but this is not complete, because if at the initial stage B or C will come, we will not accept such types of language and we reach to our trap state. Again, transition for A has been completed. Now let us try transition for B. What happen if A or C will come? No problem, we will wait for our B. If B will come, then we reach to the final state. For transition for B has been completed. For transition for C, if at the end B will come, we will accept, no problem, but if A or C will come, we will wait till the time again B comes. We can again make this by writing language L1 as we have done in a previous video, and then L2, and for that we will make deterministic finite automator D1, and for that D2, and we will try to concatenate both the DFA to get our final DFA. Try to this as your assignment work. Please try, you will definitely able to make this question. So this is assignment for this video. I will tell the answer in the next video, but before that please try this. So in this question you have to construct a minimum DFA that accepts set of all string over the alphabet A and B only, where starting with A and ending with B. This is one where the starting and ending with same symbol. So for this, first write the language. The language will be, just imagine if we start if A, then end must be end with B. A, comma B, A, and so on. A, B, A, B, but ending with A, or B, A, B. This will be our language. And similarly we can write language for it. Try to do this question different symbols. So the language will be A, B, A, B, something like that. This again, there will be infinite strings in both. So this is assignment for you in this video. We will solve in next video. Thank you for watching.